this is the focus for centripetal force. This is the do now we will be working on. So it says a toy plane flies clockwise at a constant speed in a horizontal circle of radius 6 meters. The magnitude of the acceleration of the airplane is 15 meters per second squared. And then it has this like sketch to the right. And it wants us to calculate the speed of the airplane. So I think it's nice to diagram what we know. So we know a radius. We know that there is an acceleration of 15 meters per second. Since it's in a circle, we know that is centripetal acceleration. Centri, remember from class, centri means center seeking. It's Latin for center seeking. So the centripetal force or centripetal acceleration points towards the center. It's flying at a constant speed, horizontal circle. So we want to calculate the speed of the airplane. So you're going to need to go to your reference table. Here's the reference table. These are the equations for centripetal force and acceleration. So I'm just going to zoom in a little bit. There you go. So we can see the centripetal acceleration is velocity squared over radius. So I'm going to write that up here. So v squared over radius. And then I'm going to substitute my units. So my acceleration is 15 meters per second squared equals velocity squared, which we want to solve for, and then my radius of 6 meters. Multiply by 6 meters on both sides. And when we do that, let me just pull up my calculator. 6 times 15, we get 90 equals velocity squared. And if we want to be specific with the units, when we multiply by 6 meters on this side, we're going to get meters squared over seconds squared. Which works out because then to solve for velocity, we have to take the square root, and that's also going to square root the units. So then the square root of 90 is going to be about 9.49 meters per second, and that is my speed of the airplane. All right, this next one's tricky because it's asking you to find the direction, and you have to read it carefully. So it says, state the direction of the velocity of the airplane at the instant the acceleration of the airplane is westward. So northeast, southwest. So the instant the acceleration is westward is going to be right here. So that's when the centripetal acceleration is westward. And we know that it's moving in the clockwise direction. So that means my velocity vector, which is tangent to the circle, so at a 90-degree angle in the direction, is going to be that way. So what direction is that? That is south. And that's how we would answer this focus.